All right, new day and another laptop to save, and this time we have an Alienware X15R2. This is a 15-inch gaming laptop. This is going to be one of the higher end machines, probably has like an i9 in it. This customer said they had issues with it shutting off. It said it shut off suddenly and it hasn't come back on. The power button doesn't do anything. But I haven't looked at this yet. We're going to look at it together and see if we can get this figured out. Press the power button, nothing happens. Let's go ahead and plug it in and see what the power meter reads. All right, 0.01, and then it goes to 0. Okay, so that means it's trying to turn on a power rail and it shuts off. So this should actually be sitting at 0.02 or 0.01. The fact that it's sitting at 0 probably means there's a short on the motherboard. Now, if we were sitting at 0.01, 0.02, that means that the LDO, which is a linear voltage regulator, is coming on and actually powering the EC chip, which is what's responsible for listening to this power button. But because it's pulling 0, then that we know for a fact that the none of those power rails or the linear voltage regulator that powers the EC chip is not on, so this won't work. So we're going to have to open this up and take a look inside and see if we can identify what's going on. All right, and the bottom is open. We'll take a quick look around. We've got the main battery here. It looks like a genuine Dell OEM. We've got 4 fans on this model, which is nice. It keeps it very cool. Looks like they don't have any SSDs installed. And then right behind this area, this will be the CPU, this would be the GPU. So the first thing we'll test is to see if we're getting voltage to the DC jack, which we probably are, and then just to see how far it goes and see if it gets all the way to the current sets resistor, the power of the main power rail. But we'll take a look in this area. There's going to be all the MOSFETs. Most likely these MOSFETs are going to be shut off because there has to be a short probably on the other side. So we'll figure that out. We're going to put our meter in voltage mode, and we're going to plug in the charger. Let's get under the microscope. All right, so here's where the DC jack plugs into the motherboard. So the voltage is going to be coming in here. So if I'm going to put one of my probes on ground, and we're just going to figure out which side's positive. So we have 3.3 on this pin. This is actually going to be the PSID pin. That's the communication line where the charger communicates with the laptop and tells it what wattage it is. So these are ground here, and then these are the positive 19 volts. There we go, 19.73. And so those are going to come through here. It's going to go through these inductors, and it's going to go into this MOSFET. You can see kind of the trace right there. It goes into this MOSFET. Let's see if it's coming out of this MOSFET. And this MOSFET's shut off, so it's not allowing it to go through that MOSFET, because it would come through here, then come around here, go through this MOSFET, then come out of this one, then go into this current sense resistor, and then hit the main power rail. And then the rest of these MOSFETs over here are going to be responsible for handling the charging, and then they might have another set that actually protects the motherboard too. This model is actually really good at protecting the CPU and GPU in case there's an issue. Here's what I'm going to say on this particular laptop. What I've seen is these machines use this liquid metal thermal compound. It's like a gallium-based liquid metal, and it's on the CPU. And there's actually a dam that goes around the main silicon on the CPU. But if you store this laptop in a vertical fashion, like you're putting it in your backpack or something like that, it will start to leak out the side. It can get onto the motherboard itself and start causing shorts. So that is a possibility. That could be what's going on this machine. So let's go ahead and let's go into continuity mode where it beeps when I touch the probes together. And I'm going to put one probe on ground, and we're just going to start probing through here. So we don't have a short there, don't have a short here. I don't have a short on the main power rail. Let's check over here on these guys. Nope. And what about the output over here? So we're not showing a short in this area. What I'd be interested in seeing, there's no short there either. Most likely what we're going to have to do is pull this board out. But I want to just kind of probe whatever we can. Here's another current sense resistor. We'll test that one. That one's fine. This one, this is a coil, so this is going to be an output of some sort of power supply. Now, we have this one at 14 ohms. That's probably correct. I mean, it could be a shorted component on that power rail, but it probably is one that is producing a higher wattage, and it will have a lower ohms. So let's see what else we can see on this side of the board before we have to pull the board out. This is going to be one of the Tron lights on the back that lights up the Alienware. This is the, where does this go to? I think these might go to the ports on the back. That's like the audio jack. Speakers, okay. So yeah, there's not much more over here on this side that we can look at. That's the EC chip. So that's the chip we were talking about. Let's actually measure to see if we're getting our voltage over here. So the EC chip is your Super I/O. It kind of handles your input output of like the keyboard, the power button. It will handle some touch pads. It does all sorts of different things. It's basically a microcontroller running some code, and then it's powered by that linear voltage regulator, so that can run all the time. So we should get a 3.3 over in this area. 3.2, so we are actually getting 3.2 over here. Okay, so what that means to me then is, so if we are actually getting this energized, and it is listening for power button presses, I bet we have a short somewhere else, and this chip is telling the power management chip to shut off all power from everything else. So the fact that we didn't measure a short on the main power rail kind of surprises me. But we may have a short on like the 3.3 volt power rail or the 5 volt or something like that. That's further down the chain, so we have to kind of work our way down there. So the only way to test those power rails are going to be on the other side of the board. So let's go ahead and get this motherboard removed. All right, I was taking this apart and I stopped for a second because I wanted to test something. And I took out the main battery, and then I just unplugged this junction board that powers, or that's in charge of connecting the touchpad and the keyboard and things like that. And then I just replugged this back in, and I was looking at our power meter here, and now we're sitting at 0.02, which is what we wanted. Okay, so let's see if it's turning on now. Press the power button. Nothing's happening. Let's measure the voltage on the power button. So the power button plugs into the board right here. And it should be the second pin, I think. Should be 3.2, 3.0 volts, 3.0, and then that one. So if we touch those two pins together, it should turn on. I'm looking at the power meter though. Okay, so it's not turning on still. All right, so I'm not 100% sure. So now we are getting, it looks like the EC chip is on. We measured voltage there. It's looking like it's on based on the meter. The power button's not doing anything. So let's pull the board out. I want to examine everything. We want to make sure we don't have anything obvious. We don't have any of that liquid metal spilling out everywhere, because that's something that I've seen a lot. And so let's do that. And then once we have that all figured out, this may be some sort of EC chip programming issue, because we could have the same issue with it being dead like this if we have a bad firmware on the EC chip. And programming it is a pain in the butt, but we can do it. So let me get this motherboard out. All right, and the motherboard is out. So let's take a look on this side. Here's gonna be the 3 volt and the 5 volt power rails. That's what I'm interested in looking at. I wanna make sure that we have all of our power rails, and then we can start thinking of a firmware issue versus it being hardware versus software. We're also gonna take these heatsink off and then see underneath there. A lot of times I've seen it where the liquid metal drips down and drips onto these power stages over here. I don't think that's what's happening, because we're not getting a short on the main power rail. But all right, let's check our 3 volt and 5 volt power rails. I have power plugged in here, and we got 0 volts there, 0 volts there. So but what I want to do is I want to plug it in while I'm measuring. Comes up to 3.4 and then shuts off. Check this one. 5 volts and it drops off. Okay, so that's pretty normal. To me, that means that we don't have a short at either one of those. Now those power rails aren't coming up. This actually is kind of pointing to a bad programming on the EC chip, but we're gonna keep going. We wanna disassemble this whole thing. We wanna make sure everything's good. We'll do a full board inspection, and then we'll put it back together, and then I think our next thing would be to program that EC chip. But let's get this heat sink off and see how bad it is under here. All right, so we got to be very careful taking this off, because if there is liquid metal under here, which there should be, because it doesn't look like it has been taken apart. So from the factory, they would have that on there. It can drip everywhere, so I want to be very careful we don't get it on anything. That liquid metal, if it gets on any components, it will start eating away the metal itself, because it reacts with aluminum and actually eats aluminum up. Okay, we're taking it off slowly. All right, there it is. Let's take a look at it closer. So here's the liquid metal, And it's looking good. It looks good. Let me get something. So here's our dam, this little rubber thing. And you can see it kind of interacted with it a little bit, but it did not leak out at all. And let me show you, see? This is liquid metal. And it looks like there's some thermal paste here. So it looks like it's a mix, thermal paste and liquid metal. Which I think that's what they're doing from the factory. I'm not 100%. I actually worked on another one of these machines, and I wasn't sure if they had mixed it, if somebody had opened it up and mixed it, but this one looks for sure like it's never been opened up. And then I'll show you what the heatsink looks like. And so the heatsink, see, here's all the liquid metal. Now what I've found happens with these heat sinks, you see this is copper. So gallium is supposed to be fine working with copper, but I've seen it actually eat into the metal and start having these big buildup areas where you can't even, the heatsink won't set down properly on the CPU. Now they only do it on the CPU. The GPU does not need that liquid metal. And so they just use the regular thermal paste on here. And I'm not going to be putting liquid metal back on here. The risk reward to me doesn't even make sense. So I just put TPM 7950 on here, which is great. It works almost as well as this liquid metal, and I haven't had any issues. Look, you see this? See how easy it is to get this stuff everywhere? And it does look like it actually is leaking out the edge here a little bit, or it had, but we don't have it all over the place. So we're gonna keep an eye out and see if we see any on the motherboard, but I don't see any. We're just gonna be very careful. So the way that I clean this off, because you can't just like wipe it up with the Q-tips. So I have Q-tips here, and normally I would put alcohol on my Q-tip, and you just try to wipe it up. And it doesn't stick to it very well. So I end up like holding this upside down over a trash can and kind of rubbing it, and it kind of falls and rains down into the trash. So I found that's the safest way of getting all of this off, because you don't want a single piece of this to land on the motherboard, or else it will start shorting components out, because it is highly conductive. So let me get this all cleaned off and I'll come right back. All right, I got these cleaned off, but I think this gallium-based liquid metal actually interacted with this heatsink and doing exactly what I thought it would do, or I've seen in the past. You see these little marks here? See, it's actually has some sort of buildup. And let me see if I can scrape it away here. See how it's actually hard to get off? And so if you just try to use heatsink compound and just put this right back on, it's never gonna sit flat all the way. So I'm going to have to try to get this off of here as best I can. Oh yeah, there's basically a hole here. It ate through the copper. Yeah, there's basically a hole right there, hole right there. Before I reinstall this, you can actually see the outline where the CPU goes. So before I reinstall this, I'll be cleaning this, and then I'll have to probably sand this down a little bit, or I'll figure it out. It's not too high. This is not as bad as I've seen in the past, but I usually kind of just scrape them away and keep cleaning them until I get it nice. See, there you go, it's breaking up. So anyway, I hate this stuff. I'm not going to use it. That's the point. So let me know your opinion in the comments, but I refuse to use that stuff because I've had too many nightmares with it. I don't think it's worth it. Where were we? We plugged it in. We got the power rails coming up. They're going back down. We're not seeing an obvious short on the board. The EC chip isn't the EC chip is getting power, but when we hit the power button, nothing happens. Okay, so my thought is that most likely at this point, my next step would be just to program that EC chip, because it is responsible for taking these inputs, and it's responsible for listening to the power button, and it's responsible for telling the other power supplies to come on. And the fact that when we plug this in, we see these the 3 volt and the 5 volt power rails come on for a little bit and then shut back off. It's exactly the symptom that we would have. And so I can actually enable a bypass right here. Let me show you what we can do on these boards. You can bypass, and I can make where is it at? It's this one right here. So if I short those 2 pins out, it will trick the protection circuit into turning on all the power supplies. So let me show you that real quick. Let me measure. So I have my probe on the 5 volt power rail right here. Probe's on there. We're measuring voltage. It's saying 0.023. But now if I short this out, we should get it to jump up to 5 volts. There we go, 5 volts. And all the power supplies are on now, okay, by doing this. But I guarantee, because I've done this a lot in the past, so I guarantee if I did that and just put a bridge across there and I hit the power button, nothing would happen. So this is looking exactly like a bad programming on the EC chip. And I've seen this happen because the guy was saying it just shut off in the middle of use. I don't know. I don't understand why this EC chip would get corrupted data on it, but this thing is only programmed through a BIOS update, and it's like one of the stages when you flash a BIOS. It's like flashing the main BIOS region, then it's like flashing the PD controller, and so it's flashing the EC. On some most of these other Dells, like the XPS and Latitude, the EC chip is actually reprogrammed every single time. So whenever you do a CMOS reset and you unplug all the power from the system and the battery and all that stuff, and you hold down the power, when you plug it back in, it turns on automatically. Because that's what the EC chip's responsible for, but because the EC chip got cleared, it reprograms it out of the BIOS information. Because the BIOS chips are like larger and they have the EC region in the BIOS. So anyway, but these are hard-coded, and so we're gonna have to program it. So here we go. On this machine, this is gonna be the programming headers, and we're gonna be having to attach to this one, this one, this one, and this one. And those are going to be the main ones, and then I think this one we might need a ground. We'll have to figure it out. I think it's this one we might need to hook to ground in order to put it in programming mode, but I can't remember if this model is going to require that or not. But to solder these, it's very tiny. I mean, here's my finger. Here, I'll take a piece of solder and show you that. So here's a piece of solder. So this solder is actually pretty thin, but you see my fingernail? So anyway, those things are so close together, it's really hard to solder to. So I have a special jig that I put it in, and that will allow me to hook all these programming probes to it. So let's go ahead and get that set up and see if we can get this reprogrammed. And then let's get the firmware ready. That's the other thing I want to show you. Let's get the firmware ready. Okay, so where do you get a fresh copy of the EC firmware, right? Dell doesn't offer it. Well, let me show you. We're going to get an X15. This is an R2. So we're going to get X15 R2. We're on Dell's site. Go to downloads. We're going to go select drivers. We're going to download the BIOS, but we're not going to download this version. We're going to do the down arrow. And there's other formats. So normally it's an EXE. We're going to do other formats. We're going to download this RCV. So we're going to download that. And then I'm going to rename it using this nomenclature here because it's being named BIOS image, and then I guess I had another one already in there, so it called it image 01. So we're going to rename that to that. So this is the file we need. So I'm going to cut this file. And it's funny, I was working on an X17 R1 earlier, so that's why I have that in there. So we're going to cut that, and I'm going to move that into my extraction folder, and we'll paste that in there. And I've already done this in the past, I'm sure. That's why it just said I had a copy of it in here, but I want to show you how I do it. So we're going to pull up the extracting tools. You can get this on GitHub, and this is the Dell PFS extractor. This version actually won't work on this. Alienware X15, this one. Yep. I'm going to copy the file name so I have it. Okay. So anyway, this Dell PFS extract works on Latitudes, XPSs, and a lot of them don't work on Alienware. So we need to use this one right here. It's the AMI PFAT extractor. So we're going to open that. And I just put the name of it there. We're going to extract it. And now it extracts it into a folder named the same thing. So we're going to go to that folder that it created right here. Extracted. And so if you look at this, it extracts this one file into all these different regions. And so one of them is called the OEM EC region. It's 192 kilobytes. This chip is 192 kilobytes. It's a KB 9542 GF. So this is what we want. Now we have the file that we're going to flash on here. And so now we need to set it up on our jig so we can actually program it. So let me show you how I do that. So this is a SAS EC programmer. Here I can show you the model. That's the model. I can't pronounce the name, so version 4.2. And so we're going to be using this in combination with this PC Bytes setup. This is something I bought separately. I bought it on Amazon. So these are probes that have little plungers that are super fine, and then they're weighted so they can sit down wherever you want. And then it has, we move these out of the way, it has these little holders. And this is where I can mount my board. So let's do that. So I'm going to get this lined up into these little holders. Okay. And so now if we look closely, remember these headers we had here, or these connections? This is where we can actually put each one of these, right? So we're just going to touch them right there. We can put them here, or we can put them on here. So whatever's more convenient for me when I'm setting these things up. So I just need to get the pin out for that header there, and then we'll know exactly how we can set this up. Now, there are a lot of boards that you could just program this EC chip through the keyboard header, but that's not how this board's set up. So I have to do it this way, unfortunately. All right, so here is the pinout that we have. Let's see if we can line this up the right way. So it's facing this orientation on this board. So here's the EC chip in this area and above this, and then those are the 4 pins that we're talking about. So 1, 2, 3, and 4. So we're gonna be hooking to each one of those. And, oh yeah, so it says right here. So this is we got the DO, the DI, the CS, and then the clock is in the middle right here. And then this is ground, this is the enable pin. So that's what I was saying, I may have to hook this up, I may not. Sometimes, and I only have 4 probes, and so I'd have to solder to that one. But anyway, let's get this hooked up. All right, the first one we're gonna do is gonna be the DO, and the DO is gonna be my blue probe. So the blue probe's gonna go on this first one here. We'll put it right there. And the next one's gonna be DI. And DI is going to be my yellow probe. And let's see if we can get it right there. Okay. And the next one is the clock, and the clock is green. And if we look at this, we can actually see that there's a trace that comes all the way over here, so I'm just going to plug it in over here. We just follow it. That way they're not so close together. And the last one's going to be my purple. And let's see if I can get my purple bent in there without it falling over. And I want to make sure you guys can still see too, so that's a little hard. Here, let me come around this side. I'm going to move this one over to, not that one. This is giving me issues. So this one right here, I can actually move to this spot because you can see it there. This one, I can actually move to this spot. So that gives me a little more room. Good. Now we can put our purple probe in spot number 4, which is right here. Okay, so we have our 4 probes connected, right? Our 4 probes are connected. Now there's usually a 5th one that would be connecting to, I think it's pin number 6 here. That would actually, you short the ground and it would just tell the chip that you're putting it in programming mode. But I've seen that this works without that a lot of times. I haven't done it on this board like that, but we're gonna try it. So I have to hook ground to this board, ground the board, but I gotta figure out a place to hook the ground to. We'll hook ground right there. And I'm gonna ground it to the reader or the programmer. Okay, I got that grounded. Okay, let me open up the reader though. Okay, so, all right, here's my programmer. I'm gonna plug in the USB, and we're gonna first detect that we're connected to the programmer. There we go, it says it's connected. Now it's an E&E chip. So these are all the different motherboards that you can program, but these are all programmed through the keyboard header. I have a special one that I made for this jig, and I know I updated my application recently, and it looks like it overwrote it, which is quite frustrating. So, solder only. Here, I need to open the file and see if I can edit this. I'll be right back. All right, I think I got it figured out here. So we're just gonna find a board that uses this 9542GF, which is 160 kilobyte flash. The file that we have that we extracted is 192. We're actually going to have to strip it down to 160. I forgot about that portion, that part. But anyway, we're going to choose this board. I think this is actually another Dell board. And then we're going to choose soldering as our setup, and this will tell us what the pinouts are. I already know how to do this. We're going to send that to the actual programmer, and then the next thing we have to do is actually plug it in. So let's plug it in, and we need to power up the board, so we need to power that chip. So the chip is powered, and then we're going to read, and there it is. It's reading it. So let's create a new backup here. All right, there you go. So I'm reading a backup of their file just to make sure we can put that back. And then we're going to flash a new one on there. Okay, perfect. Now we need to write a new one. And what I want to show you is the difference between the file that we have here. So this is the file we extracted from the Dell BIOS, 192 kilobytes. And the one that, we... Okay, and then the one that we backed up from their machine themselves. So we're going to open that up too. So we have them both in our hex editor here. And if we look at the data, you can see that the startings are exactly the same. If we compare them, I'm sure they're going to be different. But the size difference, right? So if we go to the end of theirs, we're going to go all the way to the end. It ends at 27 FF0. And if we measure this one, it keeps going. So we want to actually delete everything after that. So it's probably like right around here. Yep, 27 FF0. So this 2800 and beyond, we're going to delete out of this file because that's not what we need to flash onto it. So I highlight all of it, I delete it, and then we're going to save as, and I'll just name it a new one, new. There we go. And then now we have a file that we can actually flash to the device, so let's do that real quick. Okay, we're gonna write this new file to it. And that's writing right now, so we'll let that write and I'll come right back. Okay, now it's verifying. So once it writes it, that it wants to make sure that what it wrote on there is the proper, that it actually wrote properly and didn't have any bit flips or anything like that. All right, so everything went successful. We can close out of all this. So I'm gonna unplug all of this. We'll get it out of this jig, and then we can test it. Now, if this doesn't work, no harm, no foul, right? So we basically are eliminating things because the thing is that yes, this took an extra, 15 minutes or so of time, but we know for sure that we can eliminate this as being one of the issues because this is a common issue that I've found whenever we have dead machines like this that are doing this exact same issue. It's because the EC chip lost its programming, or got corrupted. Okay, I'm going to quickly do it without us reassembling or anything like that because we know how to turn it on without even the power button. So I just saw something different. You guys didn't get to see that. Let me plug it in again. Okay, look at the power meter. 3, 2, 1. Well, I saw it go to 0.04, so you guys missed out on that. But let's go ahead and trigger it on using these two first pins. I'm just going to touch these two pins together. And it's powering on. Do you see? We're pulling 2.57 amps. So you see, like the system looked like it was completely dead, like it was a physical issue, like there was some component or chip that was bad on this board. But, you know, we had to kind of follow all the clues, and the clues were pointing back to it wasn't listening to the power button for some reason. So why it got corrupted, why it shut off, I mean, maybe it was like, maybe something happened and then it corrupted it, or maybe the corruption happened. I don't know. So we are getting it to pull current. It's a high likelihood that this is fully fixed and it will just boot right back up. This is almost like a BIOS issue, except it's a firmware on one of on the EC chip, which is like a microcontroller is more like it. It's running like a loop of code that's just kind of checking GPIOs. So let's get this fully reassembled. I'm going to put some TPM 7950 on here so we can get rid of that liquid metal, and then we'll get the heatsink on. I'll clean off that spots on the heatsink. We'll blow out the fans. We'll get this thing like new and get it reassembled, and then we can test. I'll be right back. All right, the heatsinks, I was able to kind of clean off most of that liquid metal stuff there, but the fans look like they're actually pretty dirty. The heatsinks do too. So I'm going to pull these off real quick and we'll see what they reveal. Okay, let's see what the damage is. Ooh, nice. Send in the gooch collector. Wow. Okay, so let me get this cleaned up and I'll be right back. All right, we got the fan back together. It looks nice and clean. Now we can get it installed on here. All right, we got the motherboard installed. Let's see if this thing will post. I am very optimistic that it will work. Keep an eye on the power meter here. Let's plug in the power. I pulled our oh look, it automatically started pulling current, 0.2. So we got pre-charged current. Let's go ahead and see if it will post. I'm gonna hit the power button. It's gonna take a second. We got the keyboard light coming on. Remember before we weren't getting any type of reaction when we hit the power button. And because we rewrote the EC chip, we fixed the firmware on that. And so now it can actually listen to the power button. So we are getting a power on screen. I only have a 130 watt charger, so it's just giving me a warning about that. We're gonna hit F1 to continue. And my keyboard's doing nothing. So let me turn it off and turn it back on, and then we'll check the connection, make sure that it's just not a connection issue. All right, my keyboard is not responding. Let me reseat the keyboard connector real quick. It's gonna be right here. Let me pull the battery out and we'll take a look underneath. I mean, it is good news. We are getting the actual machine to turn on. We are getting a picture on the display. Keyboard actually comes over here to this junction board. This is the main connection that connects everything. So I'll just reseat it and we'll try again. All right, got it plugged in. I'm not even gonna put the battery back in right now. All right, power on. All right, F1, yay. All right, we got an Alienware screen. I was able to continue. We are gonna be inside developer mode because we reflashed that EC chip. But look, we're automatically booting the Windows. I have a test hard drive in here, so we're gonna boot the Windows and we'll run some tests and make sure everything works. This is great. We were able to repair this machine, booted the Windows. This thing has an RTX 3080. We're gonna run just a quick stress test here. And we're getting only 85 frames per second. Why do you think we're getting that? It's because we have a 130 watt charger hooked up and I have no battery plugged in. So let me connect their battery and then we'll connect their charger and then we'll see what we get after that. All right, I have their charger plugged in. I'm just gonna plug it into my power meter here. I can just plug it into the back. All right, and then now we're still in Windows. I got the battery installed and their charger plugged in. So we have the right wattage and the right battery in there. Now let's go ahead and run that stress test here. And we should get probably 240 frames per second. So this machine's successfully repaired. I think this was definitely an interesting one, and I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop!